Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a truly epic FizzBuzz tale, a coding challenge that went spectacularly and, unexpectedly, wrong. Prepare yourselves.
A FizzBuzz that didn't get the job? That's unusual. I'm intrigued. What makes this story so compelling?
It's not just any FizzBuzz. This candidate, let's call him Alex, faced a seemingly simple challenge that spiraled into a complex, multifaceted beast. The initial request was standard: write a FizzBuzz function. But then, the rules started pouring in, one after another.
Oh, I see. So it wasn't just about the basic algorithm, it was about code style, maintainability, and handling edge cases, right?
Exactly. First, there were limits on line count and character width. Then came restrictions on variable names, demanding readability and avoiding mutation. Alex initially used a clever TypeScript one-liner, but the rules kept escalating. It was a roller coaster.
And what was the turning point? What made it so difficult?
Rule 7. Numeric types, number literals, and their associated methods were forbidden. The input array had to contain string representations of numbers, with strict limitations on character sets and length. Suddenly, it wasn't a simple coding problem anymore. It was a puzzle.
So how did Alex approach this seemingly impossible task? Did he give up?
No way. Alex's brilliance shone through. He realized he didn't need to reinvent math with strings. He leveraged TypeScript's type system. Ingenious! He used types to define valid number representations, to calculate digit sums, and to categorize numbers as multiples of 3 and 5. It was a beautiful display of functional programming.
That's amazing! So he essentially used the type system to enforce the rules and perform the FizzBuzz logic? That's incredibly clever.
Precisely. His solution was elegant, concise, and met all the initial requirements. But the interviewer wasn't done yet. More rules emerged, pushing Alex's solution to its limits. The pressure must have been immense.
What kind of rules? Did they involve more constraints on the code? Or were they about handling different input types?
Both. They added rules about handling zero, empty arrays, invalid inputs, negative numbers, and even decimal numbers. Each rule seemed designed to break conventional FizzBuzz solutions. It was relentless.
And Alex kept adapting? That's impressive resilience.
Absolutely. His type-based approach proved incredibly robust. He handled all the new rules with minimal code changes. But then came the final, unexpected twist. The interviewer's partner declared that hard-coding the digit sum table was cheating. Unbelievable.
Wait, what? That seems arbitrary. Many algorithms use pre-computed tables. That's a standard optimization technique.
Exactly. It was a completely unfair rule, but Alex, under immense pressure, found a way. He switched to base 15 representation, allowing him to apply simpler divisibility checks. He was unstoppable.
Base 15? That's a creative solution. So he essentially remapped the problem to make it easier to solve within the constraints?
Yes. His final solution was incredibly compact, elegant, and robust. It met all the rules, even the absurd ones. Yet despite his amazing performance, he didn't get the job.
That's disheartening. What happened?
The article suggests he was underqualified for the senior position, lacking a university degree and specific experience. But the whole experience highlights the absurdity of some technical interviews and the disconnect between impressive technical skills and the realities of the hiring process. It's a cautionary tale.
It certainly is. It shows that technical skill isn't everything. The interview process itself needs improvement. Thanks for sharing this fascinating story. It's a reminder that sometimes the best code doesn't guarantee the best outcome.
You're welcome. And that's all the time we have for today. Thanks for tuning in to Tech Bytes and News. Join us again tomorrow for more insightful discussions. Goodbye.
Bye-bye.